About that. At least you woke up, right? The last talk of the day. It's a hot day. If you'd like, I can talk like this very quietly so you can sleep, get some rest. No? All right. Well, I am glad that you've made it all the way through to the last presentation of the day. Have you been enjoying yourself so far? Yeah? Learned lots of good stuff? Yeah? Oh, wonderful. Wonderful. Well, what I like about these conferences, and I come as a delegate, as an attendee to as many of these conferences as I present at, I like going to talks where I am already using the technology. Because if I go to a talk where I'm using the technology, I will learn new tips, I'll learn new tricks, I'll learn if I'm even using it correctly. But many people don't realize that a conference is a wonderful opportunity to get exposed to technology you're not using. And here's the analogy I like using. My wife, I love her very much. We've been married 20 years, but she's a very picky eater. When we go to a restaurant, she immediately scans for the menu for the one dish that she's had before, and she eats that. I do exactly the opposite. I go to a restaurant and I find the one dish I've never had before and I eat it. And most of the time it's delicious. Sometimes it's awful. It's squid ink and chicken eyeballs and all kinds of awful things like that. But that happens very, very rarely. And so I trust that many of you are here not because you're already using Vert.x at your organization, but you're trying to learn something new. Is anyone here using Vert.x? Oh, a couple of you are. Very good. Would you like to give the presentation? No? No? Okay. All right. So I don't anticipate that many people are using Vert.x. I haven't come across many people in my travels as a consultant who are using it. But what I like about technologies like this is even if you're not using it, you can learn a different set of patterns, a different set of usages, a different set of use cases or use stories, and you might discover that you have a real need for this. So I hope that in your last talk of the day, you'll sit back and enjoy the ride and allow us to explore not just Vert.x, but a lot of the concepts that come along with it. Shall we begin? Yeah. All right. My name is Scott Davis, but you know that at this point. You know that I run a consultancy out of Denver, Colorado called Thirstyhead, thirstyhead.com. And I've been writing books for years now. I've written books on JBoss at work. I've written books on Groovy and Grails. I've written books on Google Maps and open source mapping solutions. And most recently, I've been spending my time with the mean stack, mastering mean. Mean is a pure JavaScript stack. Mean is acronyms for MongoDB and Express.js and Angularjs and NodeJS. And the reason I'm bringing this up is as a Java developer, I have really been enjoying my time in Node.js. It's a different language. It's JavaScript, not Java. It's a different set of libraries. But what I've found is that as I am doing Node development, it makes me a better Java developer as well because I see new and different ways to accomplish things. The one drawback to Node.js, if you're a Java developer, is that you can't run Java inside of Node.js. Does this sound like foreshadowing? Does this sound like maybe one of the benefits of Vert.x that we're going to explore here? In fact, it is. So what we'll discover here is that Vert.x is very similar to Node.js. It shares a lot of similarities. But one of the key differences is Vert.x runs on the JVM, whereas Node.js runs on V8, which is Google's Chrome browser's JavaScript engine. But we're going to see a lot of similarities. So again, I hope you'll sit back and enjoy the ride as we dig into this. So Node, and I know the screen's a little bit blown out, or we've got a lot of lights on the screen here, and oh, much better. Thank you very much. Does that make it easier to see? Yeah, good. I know the text is still very small. But we see that Node.js is a platform built on Chrome's JavaScript runtime. It literally is the V8 JavaScript engine plucked out of the browser and allowing you to run it in a headless fashion. But it is JavaScript all the way down. This is right off of Node's homepage. This is their Hello World example right here. And we're going to see a couple different examples of this. But it's really nice as a Hello World because it can demonstrate a lot of key features in Node. One of the things I want to draw to your attention is this first line, this require line. As Java developers, you're used to importing packages. In Node.js, you will require modules. But effectively, you're doing the same thing, right? You can't use JavaSQL unless you import JavaX SQL. You can't use an array list unless you import JavaUtil array list. And in Node, you can't create a web server until you import the HTTP library. Now, what's especially interesting about Node.js and about JavaScript in general is that it is not just a little event-driven. Everything you do in JavaScript is asynchronous and event-driven. So in fact, what you'll see here when I go to create a server is that I have an anonymous event handler inside of this. When I create this server, every new incoming request that comes in is going to be handled by this anonymous event handler. There's the incoming request, there's the outgoing response, and so we can see that every request that comes in, we're going to set an HTTP header, we'll set some text, and send it out over the wire. Now, while this is all fine and good, let me show you a slightly more advanced version of that. This is what we have running right now. That's the example I just showed you in source code. But this example here is a little bit more idiomatic, a little bit closer to what you'll be doing in the real world. You can see along the top here, we're bringing in the HTTP module, we're bringing in the URL module, and we're bringing in some variables, environment variables as well. If we set an environment variable of port, our web server will run on that port. If not, it'll run on port 8888. These double pipes are ORs, obviously. But here is what I wanted to show you more than anything else. Let me, I'm sorry for zooming it down, but I just wanted to make sure we got at least all of it on the screen at once here. Do you remember in the previous example where that create server had an anonymous event handler on it? Well, even though you'll see that pattern, this pattern right here, over and over and over again, and not just in Node. You'll see it in jQuery as well, right? jQuery, when you're doing things, will have anonymous handlers and functions in it all over the place. There's nothing wrong with this code. It executes, it does what it's supposed to do. The problem I have with it is that it's not testable. It's hard to test. I have to actually create the server in order to test its request and response handling. And so one of the things I do every time I see those terse examples is I come in and I break that anonymous handler out into an external function that's more easily tested. So when I'm creating that server now, you can see I have a request handler up here that parses out the URL and gives us hello worlds and does a bunch of things like that. So by breaking out that function, you can see it's an external function now. I can test it independently. I can send in a mock request and write my assertions on the response and make sure that this function is behaving as expected, even outside of the context of a running web server. But by breaking these things out, you are making yourself aware of subtle bugs. As a Java programmer, I look at that and I say, okay, no big deal at all, right? I'm importing HTTP and then I'm creating a server and I'm listening on port 1337 and then I'm console logging saying, hey, the server's up and running. Do you see the bug or the potential bug? There is no guarantee that by the time you get to line 8, that server in fact is up and running. And I bring this up, and I know we're spending a lot of time in Node. Don't worry, I mean, we're gonna get into Vertex and you're gonna see the same kind of things. But I want to make you aware of this pattern that not just some things are asynchronous. Everything is asynchronous in JavaScript. And so that console log, even though it wouldn't be a showstopper bug by any stretch, I think you'd be better off using this version of the method. When I say server listen, I pass in the port and the host name, and I don't care about that third argument, but this fourth argument is the startup handler. And so just like our request handler gets invoked every time we get an incoming request, this startup handler will get invoked exactly when that server is up and running. And once that server is up and running, then I can ask it for its address or ask it for the port it's on and good things like that. Does that make sense? Yeah? Well, good. You know, this is a Vert.x class, but you got a little NodeJS training for free, huh? No extra charge. Yeah. Now, I know you're here to learn about Vert.x, so why don't we talk about Ringo.js, huh? Isn't that mean? Isn't that mean? So Ringo.js is something I talked about last year. And Ringo.js is something that I found interesting because as Java developers, you may or may not know that you have a JavaScript runtime included in your precious JDK ever since Java 1.6. We started this presentation saying Node is Google Chrome's JavaScript engine, plucked out and run headless. Well, as Java developers, guess which JavaScript engine you have? You have Mozilla Firefox's JavaScript engine, plucked out of Firefox and included with the JDK. Now, Mozilla's Firefox engine is called SpiderMonkey, but SpiderMonkey is implemented in C and C++. When they took that C and C++ code base and converted it to Java and included it in the JDK, they renamed it, they called it Rhino. So Mozilla Rhino is Firefox's JavaScript engine, plucked out of the browser and included in the JDK. Are any of you running Java 1.8 right now? Ah, yes. You got a nice upgrade to your JavaScript engine, didn't you? Yeah. In Java 1.8, you don't have Rhino, you have Nashorn. Do any of you sprechen Sie Deutsch? Nashorn is German for Rhino. Yeah. And Rhino implements ECMAScript 3 standards. It's basically an Internet Explorer 6 era JavaScript engine. A lot has changed since then. And so Nashorn is a complete ground up rewrite, fully modern JavaScript engine, including with JDK 8 and above. So when I started saying, I love Node.js, but it didn't allow me to continue to run on the JVM, I said, aha, Well, Ringo.js allows me to continue to write JavaScript, but run it on Rhino, run it on the JDK instead of on V8. And so on the Rhino homepage, they give you something that looks like this. All right, well, we have a function coming in for a request, and we know that what we want that function to return is a 200 text plain, hello world once again. So even though the syntax is different, conceptually we're doing exactly the same thing, right? And since we're in Ringo and not Node, notice what we're doing here. We're requiring in the Ringo HTTP server. And so this ends up being very similar in spirit to Node, even though the syntax is a little bit different, and certainly the platform is different. But what's special about Ringo is because it's running on the JDK, you can begin using your Java classes inside of your JavaScript applications. And it's not as weird as it sounds. If you want to include jars in it, you chuck them into a lib directory. That doesn't sound too off, does it? I mean, it's exactly what you would do in Tomcat, chuck those jars into webinflib. And then if you wanted to use these Java classes, you end up doing something like that. Now in Ringo, all of your imports, they're stored in the packages class because we're in a different language. We're in JavaScript. And when we're trying to bring in Java classes, JavaScript doesn't have any notion of imports. JavaScript doesn't have any notion of packages and things like that. So the way that you're able to use your Java classes in JavaScript in Ringo.js is by saying my user equals new packages.com.yourbusiness.user, and then you can new it up. If you wanted to use a Java-lang strict math function, this is exactly how you would do it. And you can see that if you wanted to bring in an entire jar, you could add it to the class path programmatically, which is fun. You can't do that in Java, right? Wouldn't it be nice if we could programmatically add things in? I know you can, sort of, kind of, but no one really does. But this is very mainstream right here. Go ahead and add that jar to the class path, then import the package, and then begin using it like you normally would. It's really hard to tell that this is JavaScript and not Java, but there's one dead giveaway. Do you notice it? var, right? You're varring up your variables instead of usering them up and logging them up and querying them up down there. So the upside to Ringo is that you can bring your Java classes in. The downside is you're trying to use Java classes inside of JavaScript, which is odd. Which brings us to Vert.x. You thought I'd forgotten what we were really here to talk about, didn't you? Vert.x is a lightweight, high-performance application platform for the JVM. All right, so now we've heard Node described as a platform using V8. We've heard Ringo.js described as a platform using Rhino or Nashorn. Now we have Vert.x, and it is an application platform as well. But oh, here's where it gets interesting. Write your application components in Java or JavaScript or Scala or Clojure or JRuby or Jython or any of the languages that run on the JVM. And here's the important distinction. You are not trying to run Groovy in your Java code any more than you're trying to run Clojure in your Scala code. What you're able to do are create these things called verticals. Isn't that cute? Vert.x verticals, yeah? And each one of your verticals can be written in any one of those languages. So I could have one vertical written in Groovy and another written in Ruby and another one written in Java and another one written in Clojure. And they can all communicate with each other. They don't talk to each other directly, but what Vert.x has is an event bus. And so you can have Groovy pushing messages onto the event bus, and then Scala listening on those messages and reacting and doing something with them. And then Scala could put something onto the event bus, and Java could turn around and do these things. I know that I've been coming here for 6 years, and you've probably heard me talk about being a polyglot programmer many times. Neil Ford popularized that term. Venkat is the embodiment of a polyglot programmer, right? There isn't a language that exists that he doesn't know. The entire world has to run their language through Venkat to get approval in order to push it out to the rest of us, yeah? So Vert.x is a polyglot solution. What's polyglot? It's Latin for many glots? No. Many languages. Many languages. And the beautiful thing about this is we aren't using many languages to artificially pad our resume or pump up our ego or make us sound more important than we are. What we find is that languages have natural strengths and weaknesses. Every language has its strength. If you were here earlier when I was talking about Groovy processing in JSON, it's brilliant. I almost prefer working with JSON in Groovy than I do in JavaScript. How's that? Huh? So what that means is if I was writing an application and I wanted to do the JSON manipulation part of that, I could choose to do my JSON manipulation in Groovy. But then I might decide for performance reasons that I want to use Clojure to do my functional aspect of these kinds of things. And then I might decide that I've got some legacy Java laying around and I want to incorporate that in, not because it's the best tool for the job, but because it's already been written. And so I could have 3 different verticals that would coordinate and leverage the strengths of each one of the individual languages. Does that make sense? That is the value proposition of Vert.x right here. Vert.x means you're able to leverage the strengths of each language, load up these verticals, and have them communicate with each other in a very efficient way. Now, the other thing you'll notice whenever you see keywords like non-blocking or event-driven or asynchronous, you'll see the same kind of things. And that's why we've started with Node, and I showed you these kinds of things. Vert.x is a single-threaded application server. And so you might dismiss it out of hand saying, oh, well, these toy little app servers, what could they possibly do to us? And then you discover that NodeJS is single-threaded. And Node.js in many web server comparisons outruns Apache, outruns IIS, and not by a little bit, by a huge margin. Because what Apache does is it spins up an individual thread for each incoming request. And we know that threads are very expensive to spin up, and so what Apache has to do is maintain a thread pool. And what happens if you have 100 workers in your thread pool and the 101st request comes in? Rats, yeah? And we experience this as well with database connections. Where Venkat was telling a story about that in just his very last presentation. You spin up a pool of JDBC connections, and if you fail to call the finalizer blocker, fail to close your threads out, you run out of connections. And so what Node.js does isn't do a thread-based model, it does an event-based model. Every incoming request comes in, gets pushed onto a queue. And then as there are spare cycles, it pops them off. That is what a Java project called Netty, Netty, does as well. That's what Vert.x uses under the covers, is Netty. There's another very popular web server out there called Nginx, N-G-I-N-X. Nginx uses a non-threading, event-driven way of doing these things. You'll see that a lot of these modern libraries are going with a threadless solution because, as you figured out, threading is hard, and threading is easy to fail. If you run out of threads, if you get thread starved, if you get a lot of these kinds of things. So a lot of these newer applications are foregoing threads altogether using an event-driven model, and what we're finding is they are far more performant than a traditional threaded application. So since we're required by law to write simple little 6-line web servers in every one of these new application platforms, I'm here fulfilling my obligation right here. Now, this third example that you're seeing right now, hopefully you're beginning to see a very common pattern now. Instead of requiring in HTTP, we are requiring in Vert.x, the core set of classes, the core Vert.x module. And when we bring in Vert.x, you can see what we can do here. We can create an HTTP server, and here through a nice humane fluid interface, we're tacking our request handler immediately onto that. It's a little bit clearer. Now, again, rather than using an anonymous function, I might choose to break that out into a separate testable function. But it is definitely recognizable as someone who is looking for a request path, and if it equals slash, then we'll serve up indexed HTML. Otherwise, we'll serve up whatever request path we're offering, and we're sending that file back down. So at this point, now that you've seen web servers in Node, and web servers in Ringo, and web servers in Vert.x, we begin seeing that they all can do basically the same thing in basically the same amount of lines of code, but one of them is on a really fast JavaScript engine. One of them, two of them at this point, are on really fast JVM engines. But remember, Vert.x is a polyglot app server. So this is what it looks like in JavaScript. But notice we can run servers in Java and Ruby and Groovy and Python and Clojure and Ceylon as well. So this is that same server now in Groovy. And in Groovy, we notice some interesting things. Groovy is famous for having a bunch of magical imports. You don't have to import a lot of things in Groovy. You get a lot of good, healthy defaults. And so in Groovy, Vert.x is kind of automatically imported, so we don't have to import it. We can still create a server and have a request handler. But notice what we have now in here. We don't have an anonymous function like we had in JavaScript. We have a closure because Groovy supports closures out of the box. So now all of a sudden we pass our request into our closure, figure out what we want to send, and away we go. If we wanted to do this in Java, I don't know why you would want to do it in Java. Maybe you're getting paid by the lines of code, yeah? Maybe you're looking to exercise your fingers. Maybe you have flabby fingers and you need to give them a good healthy workout. Or maybe you're a Java developer and you actually like this language. You know, I'm kidding, of course. I'm a longtime Java developer as well. But do you see how verbose Java is in comparison? Here we go. We can import our core handler and our HTTP server request, and there's our vertical that we keep talking about. Notice that our public class server extends vertical, and that is our unit of measure right here. These verticals are written in a specific language, but you can spin up multiple verticals and they communicate through a common event bus. So being able to see that class server extends vertical, and when we start that, we're going to create the server. We've got a request handler, even our, I threw up in my mouth a little bit right there, our generics, right? You can tell we're in Java doing all this kind of good stuff. But here we go, public void handle, our request. We finally get to our response, and we're listening on the same port. So I could go on and on. I could show you the same examples in Ruby and Python and Ceylon and everything else, but I think you get the idea, right? That this is the strength of Vert.x in a nutshell right here. It is every bit as event-driven and as asynchronous as Node. It is every bit as JVM-friendly as Ringo, but what it allows us to do is use our language of choice, or all of our languages of choice, and incorporate that in the same application. Does that make sense? Yeah? Good. So far, so good? Haven't lost you? No? All right. So Vert.x is kind of an interesting history. It was started by a developer named Tim Fox in 2011, and he was employed at VMware, just not to write Vert.x. It was one of those things that he started working on over coffee breaks and lunches. Of course, he was working on it nights and weekends on his own time, but then he started spending more time in the office, and his project managers would come up and say, hey, have you made any project on this over here? He's like, no, but let me show you what I've done with Vert.x. Yeah? And eventually it grew to the place where they decided to part ways. Not because they weren't impressed with what he was doing on Vert.x, it's because they were thoroughly unimpressed with the paid work he was supposed to be doing instead of working on this project. So when he left, there was a bit of a kerfuffle because he had done the majority of the development, not just while he was working at VMware, but while he was working at VMware, like during the day when he was supposed to be doing other things. And so as he left, as you can imagine, in not so congenial terms, they had to decide who really owned this. He wanted to go off and work on it full time. VMware said, we paid for you to work on this for a year. We ought to have something to show for it. There was a lot of back and forth. What eventually happened was they decided to move it to a neutral third party, the Eclipse Foundation. And what you find now is that it's had the opportunity to flourish because it's a first-class citizen, it's a real open source project, and that opens it up for other people to make contributions to it. Groovy went through a very similar process. Groovy has been sponsored by various organizations through the years, and most recently Pivotal decided that they no longer had the resources to fund development on it, so Groovy transitioned to a neutral third-party Apache Foundation. Now the good news is the folks who've been working on Groovy all this time, Guillaume Laforge and Dirk Koenig and folks like that, they were officially working on it, not unofficially working on it. So there is not the same set of hard feelings, but this again is a very common pattern. And last year, 2014, Vert.x won the most innovative Java technology award at JAX. JAX was going on this week in Germany, as a matter of fact. WJAX happens in Munich in the fall, but obviously it's a very prestigious software conference in Germany and Europe. So, what made Vert.x really stand out and earn this award? We've talked about how it's polyglot, how it supports multiple languages. We've talked about how it has this simple concurrency model, and it couldn't be more simple. You don't have any threads. Next question. You do technically, but you as a developer don't manage the threads. Vert.x, the app server, does it. And it does it in kind of an interesting way. When you're running Vert.x on a multi-core processor, it spins up one vertical per core so that it will just naturally scale based on how many cores you have on your system. There are also ways that you can spin up multiple instances, and those will be thread-based, but each vertical is guaranteed to be running on its own thread, so you never have any deadlocking issues or resource contention or things like that. It's concurrent, it's asynchronous, and we've got this event bus. Now, they're saying it's a distributed event bus because here's where it gets really interesting. you could have verticals on the server push messages on the event bus, and through WebSocket have those events pushed all the way down to a remote browser somewhere and received. Similarly, you could generate an event message on a browser, and you could be listening for that same event. So we could have real-time connection-oriented, event-driven messaging going on between browsers, one of them in Bangalore and one of them in Pune and one of them in Hyderabad and one of them in Denver, Colorado, right? It's a really interesting model, very powerful model as well. So Vert.x 2 is out right now. The latest and greatest is 2.1.5. Vert.x 3 is on its way out. 3 is really the first version that's been built under the Eclipse Foundation. So it'll be very interesting to see what it has to offer and what changes come along. But 2 is what you're going to use in production right now. And if you want to install it, you install it the way you install any other Java library these days. You bust open the tarball or the zip file, you add Vert.x home to your path, you add Vert.x home bin to your path, and then you run it. And away we go. So, if I wanted to run that web server in Vert.x, I can run server.js, deploy that vertical, here is hello Vert.x. That is the JavaScript version. I am going to spin up a Groovy version, but I want you to notice that the Groovy version will be running on port 8081, and then the Java version will be running on port 8082. There's the Groovy version. There's the Java version. One interesting thing, you can obviously deploy compiled code, but you can also deploy uncompiled code to Vert.x, and it'll do the compilation process for you. So that speeds up your development process a little bit. But what's really nice now is not only do we have a web server running on port 8080, we have another one running on port 8081. Of course, it's serving up the same file, right? And we have another one running on port 8082, again, serving up the same file. And just to prove it, I have exactly 0 servers running on port 8083, right? So being able to do that kind of thing, spin these things up and run them, away you go, is really straightforward. So now we've talked about verticals quite a bit. We also have this notion of modules. And modules are nothing more than a collection of verticals. And they can be in various languages as well and bundled up and included. We'll show you some examples of that here in just a moment. But if we wanted to spin up a raw TCP server, not a web server, it would end up looking something like this. Notice that we require in Vert.x, but this time we create a net server, not an HTTP server. And we have not an incoming request, but a socket, and then we can pump that socket back to itself. This is just putting together a simple echo server, so whatever you type in gets echoed back to the server. This is getting a little bit closer you'd need. If you want to start doing console logs and things like that, you'll have to import the Vert.x console module right there. And then you'll see that we're event-driven, much like what Venkat was demonstrating in Java 8 in this last presentation here. We have a magic method called Vert.x stop, and anytime a vertical stops, this method will get invoked. It's listening on events, and so when you bring down a vertical, it throws the stop event, and then you have an event listener here doing its thing. So everything we see on the screen is importing modules and setting up event listeners to react to that very asynchronous event-driven nature. So we've seen these requires come up, and I know this is pretty small here. Once again, we're requiring in Vert.x, or we're requiring in the Vert.x event bus. So over and over, you're going to see these patterns kind of reappear. Here's an example of a web server. Excuse me, a web client, not a web server. Notice we've implicitly required in Vert.x, and now we're creating an HTTP client, not an HTTP server. So we can bring a client, and in this case, it's doing a post. As you can imagine, we could come in there and do a put, or a get, or a delete, or a header, an option, or any of these kinds of things. But this as a client is a way that I can make an HTTP post to slash some path. And what am I going to do? Well, I'm going to have my event handler right after that. When that post is successful, I'll get the response and spit out the status code and things like that. Notice that we will want to explicitly call request end here as we're making that post request. In addition to being able to do a simple get, Vert.x offers us a get now method. And what that does is it says, all right, you know what, you're going to have a response right here, and we're going to create a buffer. And now we have a data handler event, and we have an end handler event. And so this is beginning to look an awful lot like NodeJS. When you make these kinds of requests, especially HTTP requests, it'll continue pumping the data into this buffer as it comes in, because if you've got a very large response coming down from the server can chunk it up, it can send it in pieces. And so every time our client gets a new piece, the data handler will be in here appending that piece to the buffer, appending. These are getting data events to capture that, and then when that response finally is complete, it says, yes, we're done, I'm done sending you things. That's when you could turn around and log out the content of that body. But here's an even easier way to do that. When you call get now, instead of having a data handler and an end handler, 9 times out of 10, all you really care about is saying, yeah, hide all those other events from me. Just give me something when I have the full body down. And so you can set up a body handler then that will let all of that data pumping, all that buffering going on, all that ending happen under the covers, and then all you get is the body event, so you could turn around and grab what you needed out of that. All right. Well, if you're going to be using Vert.x for a web server, One of the things you might care about is newing up a new route matcher. And then basically what it says is, now again, we're on the server side, not the client side. Notice on the HTTP client, you're able to call the post method or the put method, and that would generate a new HTTP request. On the server side, you've got the same get methods and posts and puts and things like that. But in this case, what you're saying is, when I receive an HTTP get to this URI, then go ahead and do this kind of thing. When I receive an HTTP GET request to animal cats, go ahead and do this kind of thing. So we have some nice symmetry in the APIs in that you use the same methods on your clients as you do on the server. Obviously different objects and different behaviors, but you got a lot of similarities in the APIs. And you can even have placeholders in here as well. Any of your paths that begin with a colon in front of it means that this request would be just as well for /Scott/ my trip to Bangalore, as well as /Venkat/ another trip with Scott. Yeah? But these placeholders right there, these parameters will be able to be pulled out and managed in that way. Here's what I've been itching to get you. Because these hello world examples, these little tiny examples, that's great. It really helps isolating those concepts so you can really see what's going on. But sometimes you want to see a full-fledged app and really see it in action. So Vert.x has a module registry. Now remember, a module is nothing more than a collection of verticals. And these are things that you would go and download. These modules are things like, oh look, we have a nice REST client right here. I haven't used that particular module, but what I could do is I could Vert.x install this Vert.x REST client and then see what's going on. I've got modules in there for session management. I got another REST client down here, a closure support, Python support. You get the idea that there are a number of different modules out there, and to install any of them you do a Vert.x install foo, and it copies that down to a special mods directory that then builds up over time. Now, you can see here that there are 217 modules in the Vert.x repo. $142,601 packages in the NPM registry, the Node package manager. And so this is why I'm still a Node developer and not a Vert.x developer. Vert.x has a lot of promise, especially with 3.0 coming out, the new foundation, they've got a registry in place. It's really poised for success, but this kind of third-party support out there, 56.4 million Node packages were downloaded yesterday. So you begin seeing that Vert.x has a lot of potential, but it's not even in the same ballpark as what Node has and NPM. But if you want to see some good examples, you want to know how I found this? I Googled Vert.x examples. Yeah, it's going to be one of the top hits right there. If you go out to GitHub and pull down the Vert.x examples, they've got some interesting projects in there that'll help you take your Vert.x chops to the next level. Clean up a little bit here. I don't need all those servers running. All right, so here's Vert.x examples. in here, oh, notice they're using Gradle as their build tool. I talked about Gradle in my last presentation. Yeah. So here are a number of modules. They have the modules broken out by language, so you can begin selecting the language you're interested in. I'm going to drill you into a JavaScript Angularjs example, so we can begin seeing how all this stuff fits together. Now, what I like about this example is, obviously, AngularJS is client-side JavaScript, but you're going to see some server-side JavaScript, but it's also going to be pulling in a couple of modules, one to support MongoDB connections and other things like that. Those modules were all written in Java. So we've got a bunch of server-side Java, coordinating with a bunch of server-side JavaScript, coordinating with a bunch of client-side JavaScript. And all of that is exactly working as designed. So in order to run this example, I am going to not run. You saw me saying Vert.x run server.js, Vert.x run this, run that. The Vert.x run allows you to run an individual Vert.x, an individual vertical. Run mod, as the name implies, allows you to run a module. So if I come in here now, I don't have enough hands. So if I change to the JavaScript, I change to the source JavaScript. I changed to source modules JavaScript. I knew I'd get it right eventually. Yeah. AngularJS, there we go. And now that I'm in this directory, I come in, there are my mods right there. But I run Vert.x run mod that. Don't! Oh, hey, look at this. The write operation failed to Mongo. I forgot to start up Mongo. I hope you'll forgive me. There we go. Now that Mongo's up and running, we'll run this example right here. Do I have it up and running already? Yeah, I do. We can come in here and take a look at what we've got going on in here. Every module needs to have a mod.json file. This is kind of like package.json in Node.js. This is a very simple module. It says, hey, guess what? Call app. But as we'll see for some of these other modules, they can definitely get a little bit more complex. Here we're bringing in Vert.x and we're bringing in the container. Here's our web server configuration. We're going to be running on port 8080. We are going to be actually running over HTTPS. Here are the events that are going to be coming in. A basic auth manager login event, a Mongo persister event, a Mongo persister event, right? And here we're going to deploy some modules. There's that Mongo persister module that we're looking for. Once we deploy that module, look what we have. We have an event listener that's going to load our static data up. But we're going to deploy another module, our auth module. We're going to deploy another module, our web server in there. So we're beginning to see a more full-fledged example of what's going on. What does static data look like? Well, I'm going to get a handle on my event bus. I am going to define some JSON objects in here, albums and artists and titles and prices. And what we're going to do then is basically when someone sends in a delete action, we'll walk through and delete all those things. When someone sends in a delete action on the users collection, we'll go in and delete these users. But we can see that Tim is our username and password is our password. There's my hello Vert.x. are you not running on port 8080? Let's try this again here. All right. There you go. I've shut you down. I thought I shut all you down. You're running on port 8080 there, but you're running on HTTPS. Let me bring you back up again. Localhost 8080 HTTPS. There we go. It's a wonderful thing, isn't it? Yeah? But this is an Angularjs up now. You can see that, you can imagine what it did was it made a request to pull this information out of MongoDB and present it this way. If I wanted to go ahead and log in, I could. Tim and password, so it shows me logged in at this point. And then if I want to go shopping for these things, I might decide to add a little Vanilla Ice and some bird-related songs to my shopping cart, and then I can see those items in my shopping cart down here. So these examples are very helpful because what they give you the ability to do is find some working, usable code and begin taking things from there. So there are a lot of very good examples out there, and if you Google Vert.x examples, you're going to see more hits than just that particular one I sent your way. But what I really liked about this is that in one repo, in one git clone, I had a bunch of working examples in a bunch of different languages, and especially the JavaScript ones. I was attracted to the Angularjs because that's what I use quite a bit, but they had another example in Knockout.js, and so you had a lot of good examples of a lot of different working applications in a lot of different languages. This is where I learned the most of what I learned about Vert.x, just by looking at working application and deconstructing code and putting the pieces together myself. So we covered a lot of ground here, and there's certainly more that you can do. In Node.js, you very rarely will write your own web server. You'll end up using a third-party server like Express.js. You'll say npm install Express and then begin using that. That's a Node module. Well, in Vert.x, a lot of people seem to be using Yoke for their web server as choice, rather than manually handling those requests and responses and manually setting up my routes. You end up doing something like that in Yoke, and the way you would bring this in is Vert.x install Yoke and then explore some of the examples they have along there. Not many books out on Vert.x, but several. I've got the top two there. They're both Pact Publishing. There was a very recent sale, so I picked up both of these books for under $20 US. Very good books. I haven't had an opportunity to read this O'Reilly book, but I will. But what we find is I have what I call the O'Reilly curve. When I'm trying to evaluate technologies that I want to begin talking about, one of the things I look for is there an O'Reilly book dedicated to this topic? And of course, it doesn't have to be O'Reilly. I come into Amazon, and if there are Prague books on it, or if there are A-Press books on it, if there are Rocks or Pact or things like that, that gives me a little bit more hope in the framework. Because as an author, I can tell you it takes about a year to write a book from start to finish and get it out in paper like this. And the publishers are not charitable organizations. They're only going to authorize a book that they feel that they have some hope of actually selling. So when you go to an Amazon or a bookseller and you see a couple of titles, it doesn't have to be 20 or 100 or 1,000, but if you see more than one, especially more than one across more than one publisher, you say, all right, there's enough interest in this that people have wanted to commit a year of their lives to write the book, that publishers want to sell this and hopefully turn a profit on this. There are interesting books out there. It's an interesting technology, and especially interesting to you my Java developer friends. It's interesting to you, my Groovy developer friends, and my Ruby developer friends, and my Python developer friends out there. I've not used this in production. I'm getting ready to move on to another application where they're using Grails and Scala on the back end and Angular on the front end. But what we're talking about doing is bringing in NodeJS, maybe setting up some microservices. And this is something that I definitely plan to bring their attention, saying, look, you're already a Java shop, you already have server-side Java going on. Maybe rather than asking you to burn the boats and throw away that existing code, maybe what we could do is begin implementing our microservices in Vert.x, and maybe what we can do is implement them a little bit in Groovy, a little bit in Scala, try to reuse as much of the code as you have. Maybe the front-end developers will choose to write their back-end services in JavaScript because that's their language of choice. When I look at something like this, it's got a lot of potential and a lot of opportunities if you're in the right organization with the right kinds of developers and the right skill sets. So when you come back next year, you are coming back next year, right? I'll tell you how this worked out. I'm getting ready to start with this next client in just a couple of weeks. They don't even know that I'm going to pitch them on Vert.x. You've heard it before they have. But if you come back and talk to me next year, I'll let you know how that worked out. Did you enjoy yourself? It's been a wonderful day. I hope you enjoyed yourself as much as I did. Thank you so much for your time and attention.